Hello, and welcome to the second video in the 1.12 Demonstrate Understanding of Chance and Data. So let's demonstrate understanding of chance and data. In Lesson 1, Theoretical and Experimental Probability, we'll talk about the difference between theoretical probability, like calculations and pen and paper and calculator stuff, and experimental probability, where we do an experiment to get a ballpark figure for roughly what's going to happen. At the top of the page, we define theoretical probability, which is a noun, as what we expect to happen based on theory. So, in our heads, pen and paper, calculator, calculations. Experimental probability is also a noun, and it's what we expect to happen based on experiments, by actually doing a simulation. Theoretical and experimental probability both help us understand what we can expect to happen. Unfortunately, neither theoretical nor experimental probability can tell us what will actually happen. Sorry about that. Probability is the world of guesses, and you will never get anything that tells you the next time you roll that dice it will definitely be a 6, a 1, a 3. That just doesn't happen in probability. You can say with exactitude that there is a 1 in 6 chance that you roll a 2. And that's fine. You can be exact with that, but you can't say what will happen next time. Sorry. Mathematicians decided that probabilities will be on a scale from 0, meaning impossible, to 1, meaning certain, or 0% to 100%, depending on how you want to write your probabilities. Obviously, we almost never deal with absolute impossibilities or certainties. For example, there's a small but non-zero chance you'll be hit on the head by a meteorite in the next few minutes. Small but non-zero. Therefore, we usually deal with probabilities somewhere between the extremes. We denote the probability of an event happening as P, open bracket, event, close bracket. So the probability of event A occurring is P, bracket A, end bracket. The probability of flipping a heads is P, open bracket, heads, close bracket. And the probability of being hit on the head by a meteorite in the next few minutes is P, open bracket, hit on the head by a meteorite in the next few minutes, close bracket. Although you could just shorten it to P, meteorite. This happens a lot. When we write our probabilities, we try and find the shortest possible word or phrase that will describe what we're wanting to describe without having to write out the whole sentence. So we'd want to write things like P meteorite rather than the big sentence. Fractions. Probabilities can be shown as fractions, decimals, and percentages, and you get to choose which way you do it. Each option has its own advantage. Fractions are easy to calculate and to use in calculations. If you wanted to do a half times a quarter, that's much easier to do as a fraction than in percentages. Oh my gosh, don't try and calculate with percentages. Nightmare. Just don't go there. Decimals are easy to compare different probabilities. So the difference in probability between 2/7 and 3/10. Bags not, but the difference in probability between 0.167 and 0.25, much easier. 0.25 is higher. So please don't try and compare probabilities with fractions. Use decimals instead. And percentages, they're easy for the general public to understand. So rather than saying there's a very small chance, a very close to 0 chance, we tend to say a very close to 0% chance. Or if we want to say something's very likely, we'll say it's almost 100% chance that it will happen, rather than it's almost 1, because, well, I don't know, people just might get confused. So when we're explaining, when we're telling a probability to someone who isn't maths trained, or we just want to make it as simple as possible, we'll use percentages. So each of the 3 forms, each have their own advantages. And on the number lines on the next page, we show that they're all just exactly the same. Impossible is 0, very unlikely is a quarter, or 0.25, or 25%, 50%, 0.5 and 1/2 are exactly the same things, 3/4, 0.75, 75%, and 1 and 100%. And these labels that I've put in, certain, impossible, very unlikely, unlikely, likely, and very likely, they're arbitrary, meaning that these aren't set in stone. These are labels that I've just made up. you may prefer to say it differently, and that's okay. Feel free to. But remember, you'll be communicating probabilities to other people, either in real life or in an exam. Definitely in an exam, and possibly in real life as well. And these terms are well understood. Likely meaning a greater than 50% chance, unlikely meaning less than 50% chance, very likely meaning very close to 1, and very unlikely meaning very close to 0. So feel free to use those. There's also a concept of sample space, and it's used in theoretical probability only. We write down every possibility in what's called the sample space. There's a definition here. It's a noun, and it's all of the possible outcomes. For example, you can say that the sample space of throwing 2 different colored dice, red and white, has 36 possibilities, because the red die can have 1 to 6 and the white die can have 1 to 6. So you can have the white die showing a 1 and the red die showing a 1, 2, 3, 4, 5, 6. Or the white die showing a 2 and the red die showing a 1. You can have, what's this one? The white die showing a 4 and the red die showing a 5. And because this is a rectangle, we can work out the area of that rectangle by multiplying the side lengths. So 6 down that side and 6 down that side gives you 36. An area of 36 inside there, which is the total sample space. On page 10, there's questions for this lesson. Anything to say here? Question 1 gets you to reword what we've said and written above, and question 2 gets you to compare theoretical and experimental probabilities. When you write your probabilities, write them like a mathematician would. For example, like the probability of getting a black card drawing it out of a deck is 1/2. The probability that the total of rolling 2 dice and getting a 7 is 1 in 6. Try and use the shortest possible phrase that is still specific and still makes sense, but is the shortest possible. Question 5 is an extension question. Feel free to do it. I encourage you to, but you don't have to. But I encourage you to do it. And next video we'll talk about conditional probability and expected value. But until then, see ya.